All right, today we are going to be writing algebraic equations. We've written algebraic expressions before. You don't have to add this to your notes. We've come up words that mean addition, subtraction, multiplication, and division to come up with expressions. Well, the only thing we need more than this is words that mean equal. And the primary word that means equal is the word is. He is 5. I am 10. Is, am, those, they are 15. Well, that's an equation. They equal 15. Okay, so these words mean equal. A lot of times, what do we call those? Linking verbs mean two things equal each other. There are other words too. Okay, today we're going to do it primarily through examples. So we're going to do it a little different than Alex says for this. Let's go through this. A tray has X eggs. Another tray has 3 eggs. Together, the two trays have 30 eggs. So the two trays have 30 eggs. So the two trays are going to equal 30. So we have X on one, 3 on another. So X plus 3 equals 30. This next question. Jose had X eggs. He gave his friend 3 eggs. Jose now has 30 eggs. So similarly, he started with X. He gave away 3, and now he has 30. Jose uses 3 eggs to make a cake. He wants to make X cakes. He needs 30 eggs total. So, we could write this a couple ways. One way would be 3 eggs per cake for X cakes equals 30 eggs. So 3x equals 30. That's the same as 3 times x equals 30. Jose had X eggs in the fridge. Then he used 3 of them for his cake recipe. He now has 30 eggs left. So he had X. He took away 3. He now has 30. Okay, so I want you to have written all of these equations. Okay, so back to the original problem. Which of these is X minus 3 equals 30? The second one is. And this fourth one is. Okay, sometimes you can write the equations multiple ways. Let's look at this next question. 9x equals 99. Jose finished reading his book in 9 days. Each day, he read X pages. His book has 99 pages. So for 9 days, each day he read X pages. So 9x equals 99. Or X times 9 equals 99. Okay, and a book is X pages wrong. Jose read 9 pages. He has 99 pages remaining. So he's starting with X, and he's read 9, so X minus 9 equals 99. Next, Jose read X pages yesterday and 9 pages today. Over the 2 days, he read 99 pages. So he read X yesterday plus 9 today equals 99. Next, Jose finished reading his book in X days. Each day, he read 99 pages. His book has 9 pages. Jose finished reading his book in X amount of days. Each day, he read 99 pages. His book has 9 pages. This is interesting. So if each day he read 99 and he read for X days, it'd be 99x equals 9. So he read for way less than a day. Okay, so let's see which of these equals our original problem. 9x equals 99. The only one that works for that is this first one. All right, let's do another problem similarly. Let's do part B. We'll skip part A for now. A classroom has X students. Then 2 of them went home. There are now 8 students in the room. So it had X. lost 2 of them, now has 8. Now it equals 8. There were 2 girls in a classroom, then X left. So we started with 2, then X left. There are now 8 girls in the classroom. This problem doesn't make sense logically. Alex sometimes will do that. Next, in a classroom, there are X boys. There are 2 times as many girls as boys. There are 8 girls. Okay, so in a classroom, there are X boys. There are 2 times as many girls as boys. So 2 times X is going to give you 8 girls. So if we solve this, it would be 4 boys. There are 4 boys. Sometimes solving it makes make more sense. There are 4 boys, but there are 4 times 2, so there are 8 girls. Okay, a classroom has 8 students. There are X boys and 2 girls, so there are 8 total. So X plus 2 equals 8. Okay, so looking at this, which of these equations is X minus 2 equals 8? This first one, and that's the only one. The second one would be the opposite. These are not the same. You can't flip in a subtraction problem like that. Okay? Let's do one more like this. Let's do question 3, part A. I realize you will turn in your notes, not completely done today. That's okay. Michael is X years old, and 10 years ago he was 100 years old. So now he's X, but 10 years ago he was 100 years old. So we could write X equals 10 plus 100. You could also say X minus 10 equals 100. Both of those are the same equation. Jane is X years old. In 10 more years, she'll be 100. So what she is now, plus 10, will be 100. Michael is X years old. Jane is 100 years older than Michael. Jane is 10 years old. Well, that doesn't make sense, but Michael's age plus 100 equals 10. Okay, the next one. Jane is X years old. Michael is 10 years younger than Jane. So Jane's age minus 10 years equals Michael's age. Okay, so back to our original problem. X plus 10 equals 100. The only one this works for is none of them. Oh yeah, here's one. X plus 10 equals 100. Okay. When you do these problems, it's okay if you go the other way and you try to think through each instead of like we did. All right, let's go to the next type of problem. Charmaine wrapped 21 gifts. Charmaine wrapped 7 times as many gifts as Brian. Let n be the number of gifts that Brian wrapped. So Charmaine wrapped 21, 7 times more than Brian. So Brian was way less than Charmaine. Brian wrapped n. So Brian's gifts times 7 equals 21. We could write that other ways too. You could have flipped the 7 in the end. Okay, then we need to figure out what n is. Okay, like we did the other day, we put it on a balance. We do the inverse. We divide both sides by 7. And that leaves you with 3 equals n. So n equals 3. So we should plug that back into the original and make sure it makes sense. Charmaine wrapped 21 gifts. Charmaine wrapped 7 times 3, which is 21. Elsa bought 45 books. Elsa bought 9 times as many books as Trey did. Let B be the number of books that Trey bought. This is exactly what we just did. B being Trey. So 9 times B equals 45. Put it on a T-chart. 9 times B, we can divide both by 9. You could put B times 9, same thing. So b equals 5. Then we plug it in, make sure it works. I also bought 9 times as many as 5, which is 45. Okay, next type of problem. Nicole plans to watch 2 movies each month. Write an equation to represent the total number of movies she will watch in M months. 2 movies each month. Too bad they both start with M. So the number is N and the months is M. Okay, I'm going to show you a different technique for this. It's going to be using a T-chart. So I'm starting with months. That's my independent variable. And then movies is my dependent variable. Okay, so after 1 month, she'll have watched 2 movies, 2 months, 4 movies, 3 months, 6 movies. So the way I get from months to movies is I'm multiplying by 2. So if months is M and movies is N, M times 2 equals N. So M times 2 equals N. We don't write it like this. We write it 2M equals N. Okay, we can just plug in some to check, make sure that works. Okay, the next one. Ravi purchased N notebooks. They were $4 each. Write an equation to represent the total cost that Ravi paid. Again, I'm going to use a T-chart. I'm going to put notebooks over here, and I'm going to put cost over here. Okay, so 1 notebook is $4, 2 notebooks is $8, 3 notebooks is $12. To get from N to C, I am multiplying by 4. So N times 4 equals C. 4N equals C. Okay. Next one, same thing. A gym has yoga classes. Each class has 13 students. There are C classes. Write an equation for the number of S students. 1 class, 13. 2 classes, 26. 3 classes, 39. The way I get from C to S, I'm multiplying it by 13. So 13C equals S. All right, that is how we are going to write equations. We can solve them, but for now, we're mainly writing.